So I would like to evoke power series here. I would like to remind you guys that 1 over 1 minus x can be rewritten as the sum as n goes from 0 to infinity of x to the power of n whenever the absolute value of x is less than 1. So we could rewrite our denominator here as this sum, and plugging this into our integral will give us this expression. But the problem is that it isn't quite convergent on our integral. I mean, it's absolutely not convergent on our interval, so we will have to get a little bit more creative. I mean, I still want to use power series here, but I will have to make a slight tweak in the form of my integrand in order to do so, in order to be able to do so. So how do I do it? I would like to multiply and then divide the entire integrand by e to the power of negative x. That will enable me to rewrite my integral as this thing right here. And now, well, this is something that will be convergent when I just switch at 1 over 1 minus e to the negative x by this infinite sum. And I love it because this thing here will be a finite number. I can finally, well, do something about it. So now, one more thing. This x times e to the negative x. This is absolutely independent of the variable n, so I can just slip this inside of my summation operator. And now, one more thing. The integrand is convergent. So there's no problem for me to just switch the order of summation. I can just go on and integrate first and then sum over all of those little integrals. I will get this thing here, and this is something I can deal with. I mean, I still have to make a u sub here. I would like to make a u sub of u equal to n plus 1 times x, which will make the du equal to n plus 1 times the dx, and the bounds will not change at all, because I would like to, well, get rid of that n plus 1 in the exponent of e, as you probably already noticed, yeah? So I will be left with this expression here, from which I can just take out everything that is in terms of n outside of the integral, because, well, n is independent of x. Love it. So I'm left with this thing. But now, this integral I'm left with, this resembles me something. And if you can see it, then just look at this thing here. This is the gamma function. The gamma function is this integral between 0 and infinity of t to the power of n minus 1 times e to the negative t dt, which is actually the generalized factorial function, because this function here is equal to n minus 1 factorial. And what we've got in our sum is gamma evaluated at 2, and so it is just 2 minus 1 factorial, which is 1 factorial, which is 1. And so we can just ignore this integral altogether and just take care of this sum, which will not require us to do much work, because we just have to shift the indices here in order to get this sum as n goes from 1 up to infinity of 1 over n squared, and this is something we've already evaluated on the channel. This is the famous Basel problem, and so this sum here is equal to just pi squared by 6. And that's the end. So, one more thing, I would like to wish you guys the best possible new year, and if this year was shitty, then let the next one be even better. So, yeah, that will be all for my wishes. I'm shit at it. Yeah. So I hope you guys enjoyed it, and see you in the next one.